Alright, what up guys? It's me, and welcome to another video. This one, if any of you took high school biology or even middle school biology, sometimes it's talked about in middle school as well, you're probably groaning at the title of this video. What I'm gonna do in this video is I got bored at work one day and decided to make a demonstration of mitosis in Unity. So I'm going to walk you through kind of what mitosis is really fast, and then I'm going to walk through, or I'm going to show you the demo I made. It's unfortunately a video because my laptop cannot handle all of the cells that end up being created. And I'm going to walk you through the really, really simple script that I made. So, going into it, mitosis is essentially just the process where a single cell divides itself to make two identical cells. So you have one cell, and then it splits into two. Unicellular organisms undergo mitosis to reproduce asexually, whereas multicellular organisms undergo mitosis to create new cells for growth and repair old cells. So when you get like a scrape from falling off your bike, for example, we are a multicellular organism, so our cells undergo mitosis to grow that skin back. That is mitosis. So here's a really quick look at the stages of mitosis. You have the inner phase, which is where the cell grows in size and replicates the DNA. This is the start of mitosis, and mitosis hasn't actually begun at this point. You then have the prophase, where the chromosomes condense and the nucleus disappears. I'm not going to go into super detailed things about this. I just kind of wanted to go through a little bit of what mitosis was versus just saying mitosis. So the metaphase is where they align in the center and microtubules come in and attach to the chromosomes. You then have anaphase, where everything separates out. You have the telophase, where two new nuclei, I think? I was always bad at saying that in high school. Don't come at me. They form around each set of chromosomes. And then cytokinesis is where the cytoplasm splits and you have two identical cells. So here's a diagram of the whole process. As you can see, over here, you start with one cell, and then it splits, and here you have two cells. So this is, for those of you who know about, in computer science, it is O of n time. In calculus, you get to like functions. This is an exponential function. Which essentially means that with each cycle of mitosis, the number of cells grows exponentially. And you'll see that in the demo in about 30 seconds. But from this graph here, as you can see, on the first cycle, you start with 1. Then 1 to 2, 2 to 4, and it's really not that many down here, but once you get into like the 8th cycle, you go 64 to 128, then 128 to 512, and 512 to 1024. And that's the 11th cycle. At the 11th cycle, you're at 1024, but because it's exponential, you then go to 2 to the 12th, which is 2 to the 11th is 2048. You then go to 2 to the 12th, which is 4096. And then by the time you get to the 13th cycle, you're at over 8,000 cells. So again, on the 10th cycle, you're only at 512, but when you get to cycle 13, and that's 3 more, you get to over 8,000 cells. And that's the point that this demonstration really makes. So when you're mad at your body that, like, the scab isn't healing as quickly as possible, just remember these are microorganisms. You cannot see them with the naked eye, and it's really hard to see them under a microscope as well. You got to have a pretty good microscope for it. So here is the demo that I made. All right, so you start with one cell. It duplicates to 2. Those 2 duplicate to 4. Those 4 to 16, and so on and so on. And the quality of the video just went down. I'm aware of that. That would be Canva. But as you can see, it gets really hectic really quick. Now, I had to do a couple things for this demo. I had to make it so that you could see the cells. And I also had to confine them to a space for the sake of this demo. If I just let them grow all over the place, it would have been so many more cells, and also it wouldn't have gotten the point home quite as well, because it's easier to see when it's confined into a space. So I'm going to play that one more time, just so you guys can see it. And you go 2 to 4, 4 to 8, 8 to 16, 16 to 32, 32 to 64, 64 to 128, 128 to 256, 256 to 512, 512 to 1024, 1024 to 2048, 2048 to 4096, and then you're in the 8000s. And this one keeps going because I didn't stop it in time. So I think I addressed why I created this, but like I said, I got bored at work and I kind of saw in my head how that script worked. And I went, I have an hour of spare time. I'm going to figure this out. So I figured it out. It was a really, really easy script to create. And it is one script, and I'm going to walk you guys through it in a minute here. But basically, what happens is I just have a script on the cell that has it cloning, and then when it starts cloning, it clones every 2 seconds. So this is essentially what's going on in the human body, in essentially a lot of organisms. And again, this is just a free 3D cell model. Cells are not that big. I could have made it microscopic, but then it would have taken so long and so many cell objects that I don't think my computer could have handled it. And again, the human body is obviously bigger than this box, but same difference. This is a demonstration. It's not a life-size demonstration at all. So if we go into my VS Code, as you can see, this is a really simple script, right? Really, really simple script. So I'll blow it up a little bit as well, just to make it easier to read. At the start, I'm invoking the clone method on a delay of 2 seconds. And then the clone method instantiates a new version of this game object at the transform position of this game object, and it sets the rotation to be 0. And then we're just invoking clone again with a delay of 2 seconds. And that's how you create that loop. So like I said, it is a really, really simple video and simple demo, simple script. It took longer to set up the cell in the 3D model and the box than it did to write that script. So when I made the script, I just thought I could find, a really cool and really, hopefully, educational purpose for it, and just to show that, game development can be used for something other than video games. You can make simulations like that in a program like Unity and use it for educational purposes. So guys, thank you all so much for watching. If you enjoyed, please be sure to like, subscribe, follow, do all those things, and I will see you guys in the next video. Bye.